Hello everyone, welcome to the ninth episode of FPGA Limerick. In this episode, we will take a deep look into the test bench structure of cocotb. As usual, the script of this episode has already been posted online at our companion blog, fpga.pausering.com. Here is our companion blog, fpga.pausering.com. As we know, cocotb stands for coroutine co-simulation test bench. So before we start, we might ask ourselves, what is coroutine? In multitask scenario, coroutine can be viewed as a collaborative, non-preemptive thread. And this diagram shows two coroutines calling each other with yield at every step. An execution order will always be 1, 2, 3, 4, 5. At each time, only one coroutine is active. In cocotb, the coroutine is marked by putting an async in front of a function name, and the yield is done with a wait command. We will soon see the details when it comes to the test bench next. As far as I know, there are basically two approaches to run the cocotb. One is the classic way. Or the traditional way. In the classic way, if you read the official document of cocotb, let's say here, this is the GitHub of cocotb. Let's take a look, cocotb. In the example, for let's say the first example adder, you will see what it does. It will tell you to create a make file, and the make file will, here's the template of the make file, and then in the test bench you will see every coroutine. For example, this one is marked by async, so it's a coroutine, and every test will be decorated with something like @cocotb-test. So this is how it works, and every time when you run the cocotb, those decorated by the cocotb-test will be executed. However, this is not what we will do today. What we will recommend is something different by taking advantage of the cocotb test framework. So here is the way we recommend using the cocotb test framework. What happens is that in this structure, the cocotb test is a framework based on PyTest. PyTest is a Python test framework that supports features like parameterized testing, assertion, etc., which makes unit test and regression test much easier. Also, as the test gets more and more complicated, the test bench will import a lot of third-party packages with a wide variety of versions, and the environment setup gets sophisticated as well. To deal with that and to make the test portable across different platforms, we will use TOX, T-O-X, to set up the virtual environment. So put them together. Here is what we will use as our test structure. As you can see, we will have a file called tox.ini, which creates the virtual environment. And on top of that, we will have the cocotb test or the PyTest. The PyTest will run, will look through the folders and look for all the Python file that starts with tests. And the test underscore whatever the py, those test bench will eventually launch a simulate. Either could be for now we support either Cluster or say other things like Varilate. And then those simulators will be spawned in a separate process and start the simulation. Now, to use this structure, we will need a file as here a file called tx.ini, and also a Python files, as I mentioned, with those names starts with test, and this is a requirement from PyTest to look for unit tests. So let's take a look and see how it can be executed. First, let's check out our repo and take a look at the talks.ini. I think our repo is here. And let's do this tag. Okay, let's look at the hello world test, cocotb. There are two flavors of cocotb for each simulate. One is for violate, the other is for cluster. Let's look at the one we use for cluster. Okay, here it is. So basically, the talks.ini is largely boilerplate code with the following part that can be customized. One is the required package and the version. Here is the package we use. We use cocotb, for example, 1.7.2 and cocotb-test 0.2.2. And also the environment variable, which are here. Especially if we want to use cluster.sim, we need to set up the license, and this is the one we get to set up the license, and we get that from the environment. Now let's see how we run it in the WSL. Let's make ourselves super user. Okay, now let's go to test. TB, let's go to cluster. The first time if you run it, I think we already ran it in the previous episode, but as I mentioned, if we run the first time, it will try to get packages from the internet, and it will create something called .tox, which is a folder will save all the packages. So next time, if you try it again, it will run a lot faster. The first time, it will take some time to download the packages. So once all the packages are in place, the PyTest will look for files like test, starts with the test, or the Python file starts with the test. For example, in our folder structure, here we have a file called test, and let's go NCO, which tests our NCO example in the hello world. So this is our test bench. As a convention, we will put all of our Python test code in the TB folder. This is just our convention, and let's take a look at this file. Here's our test bench. So actually, this file can be divided into a few parts. The first is the test parameters. For each DUT, it usually has some parameters, or we say generics VHDL's lingo. If you're using Verilog, it will always say parameters. And the test parameters will list all the possible parameter combinations that we would like to test. For example, in our example, we have as an NCO, so we have a base clock rate and output clock rate. Those are the two parameters we like to try with different combination. For example, this one is 100 mega base clock with 24 mega output. This is 100 mega with 10 mega output, and this is 50 mega base clock with only 99 kHz output. So we want to try those three combinations. And then here you see we also have a top folder and a gem folder on that. The gem folder, for example, we need just gem folder because we want to generate some spun HDL each time. That's why we need this gem folder. But also we will put something called a generic file in this generic.txt, which saves those parameters. Each time when we run one set of parameters, we will save it in this file. So the reason we will use this file is as we will mention later, is that because when we run the simulator will be spawned in a different process. So in order to pass parameters each time, we have to use this file. Otherwise, it will be a little bit difficult to pass parameters between those two processes. Maybe there are better ways. I don't know. But this here is our way. So please note now after that, this is our parameters we want to run, and then the second part is the test prepare. And here please notice that we have a different declaration called the py-test, mark, parameterize, and see those two parameters, or we call generics, are the ones we will use, and we will put this one here. So it will scan through those three sets of parameters. And this is the file. See, it starts with a test. So it will be executed by the PyTest. But please note that there is no async keyword in front of it. So this one is not a coroutine. It's just a regular function, Python function, that the py-test will pick up and execute. So what does in this one? First, this is optional. If you use spun HDL, you might need to run this to regenerate the spun HDL, reproduce the Verilog output or VHDL output based on the new parameters. If you use spun HDL, then say after you get all the Verilog file or VHDL files in place, you need to compile and simulate that. So here is the part you just need to compile it. You say this source, you need to put it here and then compile. If you have VHDL file, you can put it in here and compile. So this part is compile. See, compile only. Then you need to launch the simulate. Here, this is the parameters we launch for Quasta. For Verilog, we will have different set of sim arguments. So that's if you look at this Verilog, the parameters is a little bit different. Actually, as one step that put them all together, but the parameters will be different. So let's look at this is the one for Verilog, but let's look at the one for Quasta sim. So we have that, and also this GUI is from this file. You need to put this file. If you use Quasta, you can put this file here, so it will let you to pass a GUI as a command line option to the TOX. So you can do like, oh, what happened? Okay, maybe let's run again. But you can do the I think you can do the TOX to start a GUI if you like. I think this is something you can do to start a GUI if you run the Costa. Yeah, this is where you start a GUI if you like GUI. Oh, the license issue. Yeah, sorry. Okay, let's stop it. Okay, I know what happened. So as I mentioned in the previous episodes, we need to. This is because the Costa in the WSL the MAC address changes every time, so we need to do this. Okay, now I think it will be better to run the Costa. Okay, now let's run again. I think this time we don't have to download the package, so it'll be faster. Yeah, it will start the test right away. Okay, let's go back to test bench. So so anyway, this is the test bench. We will run for Costa. First it compile and then it will launch the test bench. Now here is the part that is the real test bench. You see up to this point, everything, there's no coroutine here. Everything is still just regular Python function. But up this point, see it becomes, most stuff was coroutine. And here we the test bench part we create a class called TB, a test bench. And then here is something we will take because we have two parameters and then we need to feed them into this test bench. So those are actually matches the those two parameters. Now once they get input, they will take the duty create a log and do reset and synchronous reset, etc. Let's look at, for example, this is our the file that was generated. This is our file, so it will have this synchronous reset and asynchronous reset, and also output pause, and this is the input clock. So we will need to do set them up, and also as we mentioned in the previous episodes, the way we run our, this is, oh by the way, this is our, how they mention this is our test parameter, test prepare, and this is our test bench. In the test bench, what we do is we have something called a driver and something called a monitor. Driver drives the input, and the monitor gets the output. And then we have a scoreboard, which includes a function model and a tracker, which compares the output with the model output to see if they matches. So go back to our test bench code. You will see here we have this reset, and this is our sync reset. This is our monitor part, which matches the monitor, and this is our model. Model will be called upon by the checker as another coroutine, and then this is the run coroutine, which execute starts everything. And so, and here we see we have a clock wait. A clock wait actually awaits basically is a yield. It waits for the rising edge of every clock. The run drives the clock. So this is the yield. as an await, and this is our code routine. Now, what it does is actually, as mentioned, it will take the input, and the function model will also output whatever the NCO value should be to check if it's true, it matches whatever the DOT spits out. Now, this is our just our test bench up to this point. But the last part is something called test factory, which what it does is, see, this part is also not code routine. Most code routine, the code routine is all in the test bench and in this function. This function will drive the launch the test bench. So it's itself is a code routine, and this code routine will be executed by this test factory. The test factory, what it does is just feed those two parameters, and they got those parameters from this generic file. As I mentioned in the beginning, we pass parameters through this file. So it will read out this file. It will read out this file, and it will set up the test factory, run this code routine, and this code routine will start the test bench, and then runs everything. So that is pretty much our test bench structure. Now let's take a look again. Now it runs okay. Let's run again, see how it goes. Yeah, first this part is regenerate the span HDL, so it gets reproduced the Verilog file, and then it runs the test. Since we have 3 sets, so it will run 3 iterations. So this is the first iteration. It will run in the Quasta, yeah. Spit out the value, it all matches. So this pass, and this is the second set of parameter. See here we have a new value, new parameters. Okay, so it regenerates the span HDL, run it. Okay, it all matches, and then passed. Okay, this is the third set. The last iteration was different. The base clock and the upper clock, and run again. Okay, now it all passed. So that is pretty much our test bench for cocotb. I think it can serve as a good example or template for cocotb. Let's see if there are any slides left. Okay, yeah, this is our test factory, as I mentioned. Okay, that's pretty much it. Thank you so much for watching. If you think this is helpful to you, please subscribe to this channel. Thank you so much, and see you next time. Bye-bye.